know what we need to know to solve this, but I thought I'd give it to you exactly like that. First of all, what's that look like? Yep, an equation. What type? What type are we factorising before? Starts with Q. Looks like a quadratic, correct? So below, I'd follow the same processes. I'd go up a set of brackets, correct? I'd do my x's. That's step 1 done. Step 2, I'd say, what signs am I dealing with? And I look at the second term, and that tells me what? It's a positive and a negative, because the only way I can get a negative there is if I've got a positive multiplied by a negative. If it was two negatives, this would be a positive. If it was two positives, it would be a positive. Yeah?
It doesn't matter which sign comes first.
No, it does not know which sign comes first. It's a good question. So that's step 2 done, correct? What comes after step 2? What am I looking for?
Finding the factors.
Finding the factors. Factors of 81, what are they? 81 and 1 and? 9 and 9. So I need two things that multiply together to give me negative 81 and add together to give me 0. Which set of factors are those? 9 and? Plus 9 minus 9. Cool? Well done, year 10. You've just done difference of perfect squares. Do they normally look like this? We normally write 0x. When we write that normally? Instead of writing that, we might write something like x squared minus 16. So without doing any of the factorisation stuff that we just did, what do you think is going to be there? Two sets of brackets? Correct? What's going to go first? X? What's the signs going to be?
Plus and minus.
Plus and minus? 4
4.
and 4. Now this will work for any set of square numbers. Why?
Because I've got the same number times negative.
Exactly right. Let's unpack the technique and the vocab around that. It's called the difference of perfect squares. What does difference mean in mathematics? What does the word difference mean? What's the difference between Jake's height and Nick's height? What do? We take Jake's height and we subtract Nick's height, correct? So what's the operation? Subtraction, correct? So difference means the subtraction between two terms, two things. Perfect squares, what's a perfect square number? I'll give you some. 4, 9, 25, 36, 49, 81, 64, 121, 144, 225, x squared, y squared, m squared, brackets a, b squared. They're all perfect squares. So what are square numbers?
Number times by itself.
A number times in by itself. What type of number? Is 3.2 squared? Is that going to give me a perfect square? So what type of number does it have to be? It has to be a whole number. What do we call those? Integer squared. I also said x squared or y squared. What else can be a perfect square number? A letter, a variable, a pronumeral, square. Does that make sense? So let's run through some examples of that, and then we'll go on and do some challenge stuff with. Who thinks they can give me a difference of perfect square, one that we can solve? Who reckons they can give me one? Surely someone in the room has just seen what I've done and feels they can replicate that maths.
X squared take 64.
Yep, perfect. That's question 1. I need 4 examples. Max has given me 1. You guys are going to be 3.
A squared take 36.
Okay, new example now, but however, has to have variables in both terms.
169.
Maybe wait up.
169.
Is 13 squared. Very good, very impressive. But I need variables in both terms.
4.
I need variables. How about we start with a simple one?
X squared minus 225.
Is that a variable in the second term? How about I combine marks and yours? Ready?
Can you do it?
That's 3 over 2. Alright, question 2. Well, question 1 first. X plus, Jack, can you help me out? X plus this one. In your book, look down and look up.
Yeah, that's right.
It is. X plus 8, X minus. Very good. Do you want to help with the next one? Brackets.
X plus 6, X minus 6.
Very good. Nick, you can help with the next one?
A plus B, then A minus B.
Very good. And the last one, Max?
13x plus 15y, and then 13x take 15y.
Very well done. Very impressed with that, genuinely. Very, very tricky initially. Just make sure if you're not getting it, that's okay. Ask for help. It is just an extension of factorising quadratics. It's exactly the same thing. If I'm ever struggling with that, what could I do? I could go to tutoring. We could look at some baseline issues, but I could always extend it back to that form there, couldn't I? Because everyone in the room got that without me even teaching you anything about factorising with difference of perfect squares. Sweet? So, I want you to have a go at the challenges, even if you're struggling a little bit. Have a go at them. I'll put some softer challenges on the left-hand side of the board in a second. Yeah.